I'm going to go ahead and introduce our next presenter. We are working on the screen just to make sure that flicker goes away. I'd like to introduce you to Mr. John D. Hart. He is a seasoned systems engineer and digital engineer at Avian. He has over 25 years of experience in the aerospace industry. His expertise lies in systems modeling and simulation, having worked for several major aerospace companies throughout his career. Over the past decade, John has held various positions as a mechanical, electromechanical, and controls engineer with a focus on multidisciplinary and systems engineering. He has worked on numerous development programs, as he said, some weapons, some missiles, and some airplanes, and other projects related to aircraft and weapons systems. John earned his MS in systems engineering from the Georgia Institute of Technology. So welcome. Thank you very much. Thank you. And let's get your mic turned on.
It's on.
Yep.
There we go. All right. Wow. Thank you. So let's go ahead and get started then. So first of all, thanks for having me. I appreciate the opportunity to talk. This is fun. A little nerve-wracking, but still fun. I'm working with a little company called, well, let's just start here, creating mission models. I'm not going to blow your socks off with a mission model today, but I will show you part of how to start modeling a mission. And part of the discussion will be around some of the things I'm seeing in modeling that are unusual for a guy who's been modeling so long. So I'm seeing a lot of unusual methodologies. The models look weird to me sometimes. I'm going to kind of show some of that and why I think it looks weird. So we will create a little mission. We're just going to work on the laydown of the mission. So that's kind of like the start of the mission. We're not actually going to simulate anything. I don't have any behaviors in the model. It's just it'd have been a 2 or 3 hour discussion. So there's me. There's my mug. Nice. Here's a little background about my company. I work for a small company now. I used to work for guys like Lockheed and the big boys. I moved to, wanted to help the Navy out. They work directly with NavAir. I felt like it was something fun to do. I grew up Navy. My father was in the Navy for 15 years, I think. So I grew up in San Diego, traveled around quite a bit. But what this little company is trying to do is really make a push into this world, which is, we use the term MBSE a lot, but really it's digital engineering. That's kind of an odd term to me also. We've been doing digital engineering for a while. It's really engineering, systems engineering with some automation. We're trying to stuff it all together to make it work consistently and be more, more structured. So a quick talk here, mission modeling in SysML. It doesn't really matter what language. I use the term SysML because that's what we're talking about here. I don't care what language it is. We're modeling a mission. And so the first thing I always do when I model anything, is I ask, what is it going to do? I don't hear much of that. I don't even see, objectives. I don't see very many scoping events to determine what the model should look like, what the model should be doing. But to me, the model is used to inform. It tells something else what to do when you make the model. So I'm already thinking about that when I start modeling in Cameo or any kind of tool, Rhapsody, doesn't matter, even just writing some code. I'm already thinking about what is it going to inform? What is it telling its customer? It's telling something to do something. So the nice thing about that is when you think about it like that, and when it starts happening, when the little loop starts happening, your model will be informed back. So the other tools will tell your model what to look like. So you don't have to go in there and just kind of hope you got your model right, and then you start modeling in Cameo, and you end up with this weed of a model rather than a very focused model that tells something else what to do. So a quick one here is, it informs, what does it inform? Document, simulation, analysis, that's what really generally they inform. But for the mission modeling aspects here, when you think of a mission model, people think of the model, and I can show you I have an example of what that looks like when they think of it kind of in an odd way. They think of the mission model as an entity, like I'm making a giant mission model. And so just like if you see an airplane, when you think of an airplane, it seems magical until you break it down. It's like, what is the airplane? It's an empennage, landing gear, wings. Same thing with the mission model. It's a setup, it's a gameplay, and then it's an analysis. you're going to be just like playing chess. So you've got to set the board up. There's a bunch of rules you got to set up. What we're going to do, I'll show today, is just you're going to set this up right now. We're going to set the rules up first. Then you can go play the game later. I'm not there yet. With at least I can't do it in this presentation. It would take too long. So there's that. A little bit of some observations up front. We'll just show a little laydown model for a mission. I'll show an example of an arrow, and I'll talk to you about what an arrow is in a minute, and then we'll wrap it up. So this is a little bit of a weird slide, but the reason why I put this slide up here is because I've been using modeling tools since, I don't know, the early 90s maybe, and we've always had a model given to us. As an engineer, I'm making an instance with a model right here, and this is STK. The model's here. It's already given to us. It's already built. As a systems engineer, we don't really have a model over here. We have to make the model ourselves. So there's an example of this is a very simple model, but very powerful. That model right there can configure any tree that at least within the constraints of that model. I can add a trunk, and I can add any number of branches. Then I can add any number of branches to branches, and I can add any number of leaves, and then I can configure any tree I want. And so I think of this when I start modeling. How do I use SysML or Cameo to do this kind of work? Because this is what I'm used to doing. This is how I did it, and I still kind of think that way. Maybe that's old school, but I think it does translate if you think about it. If you use the right tools in Cameo. So let's see here. Yeah, so I'm really looking for a way to build that kind of instance by right-clicking and adding an airplane, right-clicking and adding a weapon to the airplane, and so on. So this is just kind of a precursor. Look, you got to have, a very clear purpose for your model, even if it's a mission model, because if you don't, you're going to think of it as a giant mission model rather than breaking it down into it's essentially a laydown, a behavioral model, and then some sort of analytical model. That's what you're making when you make a mission model. So what's the model informing? Again, really important to think about that way. And then, do you need to inform structure? Because that's kind of hard to do. How do you rip the structure out of Cameo? Do you even need to do that? Many times I have to do that. So I'll show you how to do that today. We have a little tool set that you can do that with and practice with. And then another thing is what does the mission model do? What's one of its purposes? Generally, it's pushing out a set of mission critical parameters. That's what it's generally pushing out to the rest of the world. I'll also say here that this is a pet peeve of mine. I see this kind of stuff all the time. We got a systems model, we got a simulation, we got an analysis, and people just draw arrows between them. That's not an arrow. It's like a very complex piece of software that translates the information from one tool to the other. I'll show you one today. And it's not an arrow. It's really hard to do those. And I see this all the time in systems planning. They're like planning for a big model. They put the arrow in there, no NRE associated with it. So it's like, it doesn't even, your model, you're off by an order of magnitude if you don't consider those two arrows. All right, so last thing. This is kind of just a description this is kind of the last precursor slide. This is a description of what I'm seeing in the modeling world. So when I sit down, I look at a Cameo model, and this is directly happening now with mission modeling. I see things like, I see this. What is this? This is a list of words to me. It doesn't really, I don't know what this even means to me. When I look at it, I find that, assume this is some sort of mission to go buy bread. So you get in the car, you start the car, you drive to the store, so on. And then I'm seeing this in a Cameo model. I'm like, what is this? Hey, has anybody thought about what goes behind that drive to the store? That's a huge model. It's so complex, it's like crazy. So we're kind of just, I don't know how to explain this. I don't want to complain. I'm just saying I'm seeing models like this. I'm arguing this right now, which is this doesn't make sense to me if I were to say, build me a mission model and somebody gave that back to me. Because what's it inform? It doesn't inform anything. It's a list of words. It doesn't inform a mission on how to set up, and then how to play, and then how to analyze itself. There's no feedback loop. There's no controls. It's just a basic list. So it's I'm kind of complaining a little bit, but it's, what information, if I'm sending information from the systems model to a simulation. What information does a simulation need? All of it. It's not one or two pieces. It's everything. You have to tell, it's dumb. It doesn't know what to do. You got to tell it where every part is. You got to tell it where every behavior's at. If you want to use a template, that's a great way to do this. Generate a template between the simulation and the systems model, and then you can scope down what you're telling the simulation to do, because you can have some pre-built methods there. But still, whatever needs to be informed, it's not the analyst's job, it's not the simulation engineer's job to know what you're wanting to do. You got to tell them everything, the whole thing. So, finally, for the first, kind of the prep slides here, here's a nice little mission model. And it doesn't have all the attributes shown, but it's only 5 blocks. It's really just a few blocks to lay the sim down. So I can make any configuration just like I could in STK with that. But it's not clear how to do that in Cameo. And for many of the new, younger starting off modelers anyway. I want to do this in Cameo. I want to right-click, add a vignette. I want to right-click, add a group. I want to right-click, add some platforms to the group. I want to right-click, add a force, stuff some aircraft into the force. So how do you do that? Well, I mentioned the tree view because, again, it's how I think. I can program a little bit, and I use these tree views over and over and over again. Not just me. Cameo uses it in the containment tree. CATIA, every CAD modeling tool you've ever used, same thing, tree view. So it's a good way to think about the mission when you're laying out a mission model. Think of it as a tree view, and you're going to have kind of like a pre-configured set already of what the model might look like. Sorry, one more. So thinking about model structure, again, what's it informing? You're going to have mission config. You know that. So this is the start of your mission. You're going to set this up. You're going to tell where every piece is at on the board, just like laying out a game of Risk. When you play Risk, you lay the board out first. You have to. You have a set of rules. You lay your parts down per the rules, and that sets the game up. And then you play the game. So after you mission config, you play the game with these. You have some pre-configured libraries, and you have some conformer, actual configuration of a performer, which we're not doing this here. I was actually going to go down the path of talking about doing some military setup. We're just going to do a real simple, very small model setup today. So again, if I'm planning on using an agent-based modeling tool, guess what? That kind of tells my model what to look like. It's telling my model, hey, I'm going to need these things. So let the other tools tell you what you should be making in your model. Don't generate another siloed, now all of a sudden we got all these systems engineers modeling, and if we don't think about the rest of the world, then you end up making another silo rather than figuring out how to actually integrate all this stuff. All right, so this is going to be quick. I would just, I didn't want to build it from scratch because it would take, it's probably going to break if I do that. So a simple mission here. I have this remote. The idea here just kind of, the reason why I picked this is because I've already kind of spent some time designing a model for this pretty complicated model. But the idea is, this is kind of like a laydown, a descriptive diagram of what that model could contain, sort of like an OV1 diagram. But essentially, we have some drones that are at a hospital in the city. We have some remote hospitals that have charge stations. We have some emergency calls. I'm not going to make any calls today, request calls, but these need to be modeled. It's going to be fun to model that in Cameo. Think about how the other tool informs on how to make that. That's really about it, what we're going to do right now. Emergency and standard response rates. So if I go to the model here, and we'll just make one real quick. So I'm just going to drag these in. Let me talk about them real quick. So the mission model, what does it need, right? It needs some, if I go back to the slide again, it needs some locations of the hospitals. It needs maybe amount of, how much medical material does each hospital have? A few things like this. I'm going to drag in a RMSS. So I made this little mission block. It's just a mission block, no big deal. And it contains some hospitals and some drones. So we'll drag these in here and just show them. Now, again, I'm not going to blow anybody's mind here. This is a really basic model. But the idea should be coming to you. Oh, look, I've got a hospital. It's got an XY location. I tell it what type it is. I tell it how much medicine it has there. Same thing with the drone. It's got a speed, a flight range, a capacity. So if I also drag in a charging station, that's going to be part of the hospital. And I think that's it, isn't it? Am I missing something there? Drone, hospital, medicine. Oh, medicine. So silly little model, but it's not trivial. This model now can be used to create any instance I want of this setup. I can have any number of hospitals, any number of drones, any location of hospitals, any location of drones, so I can inform the simulation model of where everything's at. What does it look like? Where's it at? How much does it have? What's important to the sim? And so let's go ahead and make an actual instance of this. And then what I'm going to do is make an instance of this and then stop and go, what do I do next? Okay, now I got an instance. Now what? So I'm going to take that instance. I'm going to rip it out of the model. I'm going to go interrogate the instance. Then I'm going to produce a JSON file of that instance in a very clean, clear format so that you can read that. Anybody can read it. You can take a piece of paper and read it, or you can read it with another computer. Doesn't matter. So let's make an instance here real quick. So down here in the instance box, or in the instance package, I've already got 3 pre-configured instance tables. So the instance tables, this is interesting. It's interesting to do it this way because it almost mimics right-clicking in the tree if you set your table up like this. So if you make let's make a RMSS mission. We'll call this, let's rename it so we see it. And we'll make a hospital here. We just add a hospital. So you double click and add a hospital. Double click, add another hospital. And they show up nested. Everybody's seen this, but this works great for doing this kind of stuff. So you got a drone, another drone. And then we can have a standard response, time. This is a MOE and maybe 20, I don't know, MOP. Really simple, but very powerful now because I can go in here and then update this, update each part. Let's see, cargo capacity is 5, 50, 1, sorry. And then we'll go ahead now and set the hospitals up. And you certainly could read this in from an Excel file or automate the process with some sort of behavioral export, import tool. But here we're going to add a charging station to this one. We'll add a location. This is going to be a rural hospital because it's got a charging station. So let's go ahead and say it's true. It is rural. This one's false. We're going to have this guy in the center. This hospital 1 here is the center. Let's call it city. And then this is rural. All right, and we'll make him 11 and 12. And this is because my agent-based tool is asking for this. So he's got a lot of medicine. He has very little medicine. I can't add a charging rate here because there's no charger. There's no charging station, so I can add it here though. 100, 1200.
Is this pointing to all one instance element?
Mm-hmm.
It's all, so all of these different tables are all...
They're right there, looking at that one beat.
One instant element.
Yeah.
Okay.
So I just go ahead and scope it to that demo folder, and inside here I grab each one. I had hospital and this one, of course, for hospitals, drones here. So now what? I got this instance done. So what do I do with this? How do I even analyze this mission instance? Well, in this case, we're not going to analyze it or simulate it. We're just going to set it up. Now, what do I do? How do I get this out of the model? Well, there's a couple ways of doing this. I have, let me think, I had a slide here. So yeah, there they are. You can see these instance tables, but these are great. This is very trivial, but you can have, like for an airplane, this comes out great. You can actually build you a real nice airplane in a tree view format here. We just kind of drug those out, hospital, drone. There's several versions of different configurations here. And again, I'm kind of cutting, something I wouldn't normally do is make a single instance and then use it. That doesn't make sense. I would normally make something that is statistical in nature, so you can vary the instance real quickly. Here, I'm just doing one-off so we can get the concepts down. but not something I would normally do like this. All right, so now what? I have an instance. How do I use this instance? I don't know what to even do with this thing. It's just some information in a model. Well, we can use the MD-zip file, and we can interrogate that XMI. I have some tools in Python that can do that. Open an MD-zip file and interrogate the model for information and pull it out in Python or whatever tool I'm using. XML is great. You can export the model to using XML to GitHub or some sort of repo. And then it's great because it's versioned text data. But really, Teamwork Cloud has this API, and it's great. And it turns out, if you get into the API world and you study it, you can pretty much you don't even need Cameo to make your models. You can make all your models directly from the API. It has all the operations available for the most part that Cameo does. So in this case, you can, create, update, delete, whatever you want to do from Cameo or from the API with an external tool. Another big benefit is SysML version 2 is coming out here soon, and their pilot implementation already has an API built into it. It's great. So it's like, it was super powerful right out of the box. We didn't have to wait for it or learn about it later. So that's coming down the road pretty soon. So let's do this. So I'm going to go ahead and show you a little piece of middleware here. This is an arrow. This is like what an arrow would look like. So let me save this, and I'll push it up here. Let's commit it. All right, so now I've pushed the model up to our Teamwork Cloud instance, if this works. Ah, good, it's working. And this is where the hard part comes in. So now I have this, let me close that down. I have to build a piece of software to do this. It's not trivial. It takes some time. It's about, I don't know, I made this for this class to show how we might do this. It's a bunch of code that I did not want to write, and it was painful. And by the way, a lot of this, especially the front end here, was written by GPT. I asked it how to write a front end, and it did it for me. No joke. It was crazy. One Saturday morning. So I got a cool little tool here that can look into Cameo or look into Teamwork Cloud through the API. I'll run it here, and you can see, again, I wouldn't ever build a GUI. None of this. I don't do any GUIs. I only do scripts and automation. So I would never build a GUI. This is just so you can kind of see into what I'm doing or what I'm trying to talk about. But the overhead of these GUIs is a mess. The overhead of having I think in some respects, I find the overhead of Cameo to be a painful thing to see because you got all this user interaction going on there, and you're adding all this complexity to something that's really not that tough sometimes when you just look at the modeling part, not the user interface tools. So this little tool here, I can connect to our Teamwork Cloud instance, and you can see in the background here, I'm making calls to Teamwork Cloud. I've connected, and I can look at all of our workspaces in there. So I can actually go to the mission demos, which is where I was working at. You can see it calling them. Was I working in demo? Let's see here. Demo, yeah. So I can interrogate demo, the model demo. Now I've ripped the entire model out of Teamwork Cloud and put it into my memory. The whole model, every element, everything is right here. So there's B. There's the original RMSS. You can look at it, a charging station. Now I can look at it in a tree view and see it. I can interrogate it, look inside of it. What's in here? This is the kind of stuff you're going to want to see when you move models from point to point and move them around. This tells you that its name. It tells you that it has some components. What does it own? This one is let's see here. Let me zoom out. Tells you what type it is. So it's an instance specification. Tells you this is a slot that has a literal reel in it. I knew that. I can also double click on this and change it. So now I can go to, this is now updating the model in Teamwork Cloud. So if I reconnect and I pull it back in, come on. Big model. It was a charging station. you can see it's in change. So I just reconnected to Teamwork Cloud, pulled it in, it updated the model. There's some problems there. How do you handle commits? It actually had to change the model and commit that, and it was a mess. So that's fun. It's a neat feature, but when you get into it seriously, how would you actually do this? It becomes pretty complicated to figure out how to actually do that commit cycle there. It's not trivial anyway. So if we look at the model now, the model here is B. You can see there's my whole model. Everything's in there. The model itself, there's my standard response and emergency response times with the values, the literal reals or whatever they are. I think they're reals, yeah. Hospitals, hospital rural. This one's got an XY location. That's great. This is awesome. But now what? I mean, what do I do with this now? I'm in the same bind I was in when I had it in Cameo. So I've got to do something with this. And this is kind of how I like to do things. I don't like to go build special plugins for Cameo. I don't like to go build special plugins for AppSim or SDK either. I want to have a middleware that's agnostic to on both ends. I think that's important. Otherwise, you just get locked in. So I'll export this. I want to export this as a really pretty JSON file. So let's do that. Export the instance. I want to call it, what was it called? I can't remember what I called it. We'll call it something, RMSSB. B1. And so I exported it there, so I can go back to, I'm looking at, I'm using VS Code here. I also really like to use Jupyter Lab too when I'm developing this stuff. It's great. You'll see down here in the models, there should be a B1. There it is. And there's the JSON file. So I've generated this really pretty, easy to read, easy for somebody else to understand image of my instance in Cameo that anybody outside of the world can see this and understand it right away. This is very easy to understand. So, and we're used to JSON, so all the tools are available for ingesting this into Python. 2 seconds. It's no big deal. So now what? So now we're still stuck again. I got to do something with this. So somebody has to ingest this and turn this into a layout of a mission. So I continued building this tool out, and I kind of ran out of time. It still works, but it's not generic in nature. It's almost like you got to do it exactly right. So I will export that JSON file into a set of CSVs that I can read into a small little tool I have, which is called Netlogo. Netlogo looks like a joke, like a little toy. Is not. It's awesome, and it's very powerful. And by the way, the Logo language has been around since I was a kid, so there's a ton of history there that you can go leverage if you want to start using this as a mission modeler right away and not pay for SDK. That meaning you can use this for almost 90% of your mission modeling needs up front, early on, and it's free, right out of Northwestern, I think. So let me export this, make sure that works. I'm gonna just make these three data sets here. So I will export it. I'm gonna read that JSON B1 in, then it's gonna put it in the same folder and overwrite those. And so now if I look in here, you can see I have my drone data, my hospital data, and my model data. That's the 2 MOEs. So now what? Still stuck because you got to pull that in. So I have this very simple Netlogo modeling tool. Unfortunately, that's not pretty. It doesn't look great here. We're just showing one-offs. This thing can get really fun, and you can really build a complex model here that is very powerful. And I'll show you one real quick at the end of the class that goes nuts, and it's pretty interesting. So, oh yeah, we're doing great in time. Heck, I'm going too fast. Let's see here. So I'm going to take a look at the code real quick and just show you what this looks like. It is just some very simple code that reads in these CSV files and then places those components onto the canvas, if you will, or into the arena for the game. I'm just setting the game up right now. So if I go back and I just hit setup, it'll read those, and there's my hospital. So that hospital was at 1112. This hospital is at 00. You can also see that there's some, if you slide over, you can see there's some airplanes in there for UAVs, and those UAVs we can start, if we had transferred the behavioral components, we could start modeling this and running it. One thing to note is don't be afraid of the behavioral transfers. They're just text. It's just text files. Your states and your activities, operations, they come out looking like text files when you go rip them out of there. So you just format your text file right, then whoever needs it, and it can be in a JSON format too. Whoever needs to read it can then take it and either just look at it and recreate that by hand, which is not what we want, but easily do that, or ingest that into AppSim or SDK and automate the behavioral development there too. So, and you can take some cues off of, they have an export here for OpenModelica. So you can export, OpenModelica is great, super powerful tool also. And if you export your behaviors with Modelica, it gives you an example of what the behaviors will look like. So you can kind of mimic that or just use it. If you want to just export Modelica, then figure out how to import that with the other, if you're using Modelica or some other tool, you can do that. So let's see here. For fun, we can just go back through this real quick. One last cycle. Yeah, that was pretty quick actually. That was faster than I thought. We can wrap it up here a little early. It's good. It's the end of the day. So if I were to just fiddle around here, I could add another, add another hospital. Oh, hold on. Got to do it in here. So add another hospital. There it is. The hospital is now here. I want to make this -11 and -12. It's whatever. Okay. So save this. I commit it back up to the server. Done. Yep. Oh, it's asking me to update because I changed that one value earlier. So it's pushed back up to Teamwork Cloud. Now I can go to my little GUI. I can connect again. Uh-oh. Did it connect? Let's see. It did. So I'll connect again. I will look in the mission model. I will look at the demo. I will look at this instance again. It takes a while to pull these in. There's a lot of elements in this thing. RMSB. I will export the instance to JSON B1 again. Yes. I will then export the CSV files. And I'm going to read JSON B1 in to export the CSV files to the same folder. And when I update my mission model, you'll see the new mission laydown is there. So that's, that's doing it from left to right. It's just, I always think of the systems model on the left. I think of all the other tools on the right in my mind. I don't know why, just I do. And so you can imagine I could run this and then I can, through the same mechanism, Teamwork Cloud mechanism and API, I could inform the systems model of the response times. So we could, imagine the two response numbers, we can just pump them right back into Cameo, no sweat. So let's see. Yeah, there's the summary, and I kind of as a smart alecky comment. That's an arrow. That arrow was no joke. It takes a lot of time. Got to account for those arrows when you build this kind of workflow tools. A little less complicated when you just do it without a GUI. The GUIs are not. I don't find them useful. Really, you want to just make a workflow either use a workflow tool or make a code deck with it. So before I get into the summary here, went quick. That's good. I will show you for fun. And by the way, all this stuff, all this code, everything here is up on GitHub. You can go grab it, tear it up, tell me it stinks, whatever you want to do. You can go have some fun with it. But it's good in that it has two things up there. One is I have all these models, including some pretty complicated models that I built in Netlogo. But I also put together a really nice, but I reference it all the time. So I put together this really nice Jupyter Lab notebook. Here it is. And this has all the steps in here, how to interact with the API. So you can just walk down this notebook here. Everything I did, I show what I did and why I did it, and I note exactly how to do it. So it's all here. Also, this is kind of very low level version of that. I would not, again, do this. I would like to see this. I haven't seen one, which is kind of weird. It's some sort of Python package which collapses this into something more usable for a general user. Because it's right now, you see I'm actually in there writing down details. I'm having to break out what's inside each element and then figure out how to get that information out of it. So it's all here. You can have it. It's up there in that same folder. This is also a good primer if you want to learn JupyterLab. I actually go in there, I rip out all the literal. If you have a model and you point to it, you can rip out all the literal reals of a model and then generate a stack of however many reals you have that you can then edit and then push back into the model for fun, for test purposes. So there it is. But what else was I saying? Oh, I was going to show you that other model. Yeah. So for fun, we could just look at this and then call it a day. So where'd my Netlogo go? If I were to really do this, let's not waste this time. I can actually say something here. This model, a lot of times I do this from this method. I start with a simulation model first. Then I use it to tell me what I need to do on the other side. So that's kind of a different way. It's because I know how to build sim tools, sim models. That's probably not a common thing around all the systems folks, but that helps me. I start both of them ringing back and forth immediately, and then all of a sudden my model will not look like what we thought it was going to look like. So it gets better and better every time. Here's a complicated version of this RMSS, actual simulator. And so this version here it reads in. I can tell it what city. It reads in all the hospitals around the city, and then you can you can run this stuff. So here's Atlanta. These are city hospitals here. The blue ones are actual remote hospitals. There are drones here that will fly and pick up some medicine. There's message queues here. There's first in, first out message queues. There's priority message queues. It gets tough to build because you don't want to build a one-off instance. That's no good. This is kind of an instance of a model that is completely variable. I can set the number of drones in the model. I can you can see that when I click setup, the drone types just randomly select each other because I'm going to run this in some sort of simulation. I'm going to run an analysis, sensitivity studies. I'm going to run some sort of optimization. So I need to be able to have this real generic model here. And once I set it up like this, then it tells my systems model, hey, you got to have density functions. You got to have some sort of ranges for these. If you do the sensitivity study first here, then you can really cull down the model because you know what's not important and what is important. So at least you from your first pass. So if I run this, you can see they're going nuts. Let me slow it down so you can see it. But I'm measuring the response time. I'm measuring the speed of how long it takes. And so this tool here is great. It's very, very powerful, and you can have some fun if you take it seriously. People don't like it because it looks like a toy, but I've used this, outside of SDK. I'm a pretty good SDK user. I've used this outside of SDK many times to model complex missile systems integration models for battlefield and other weapon setups, and it's a great first pass, great first cut. So you can see the model blew up right there. It's telling me it doesn't work. So you can fiddle around with it, but really you got to hook this up to something like an analysis tool. So yeah, while we're here, I'll show you that too. You can see I have, let's see, I have it actually. Where the heck is it? Yeah, here it is. So if you want to, I think I actually included these in here too. So
I gotta say, this is amazing because you're bringing this really complicated stuff down to a mortal level.
Look.
I identify with the way you're approaching this
Mm-hmm.
and going at it, and knowing that you can do this kind of thing without having to dive into months of Java to add a plugin or something like that, it kind of resets my mind as to what's possible here.
Yeah, I kind of grew up doing this stuff. So when I see a giant systems model, which is what I always see right now, like some crazy model, I know something's wrong right away because I only make very big baby models. They're like ridiculously small, very simple models. Then I test it. Then I make another very tiny model. Then I test it, and I make another one. And then after I have enough that I want to go to the next level, I've tested them. You put them together, make a little bit bigger model, test it again. Don't assume it works. Then build some more models at that level, and then squeeze them together and keep going up. Right now, I can't even look at some of the models because they're so big. You can't present them. You can't get them onto documentation. We don't have a real good strategy for even how to read into the model and see what it's doing. So it's nicer to me, just learned over the years, very small models, very simple models, almost dumb models. But when you, just like behaviors, 4 or 5 very simple behaviors added together makes a super complex behavior that you never even anticipated would come out of those 4 or 5 behaviors. So same thing with models. Keep your models simple, stick them all together, and then you won't get lost. You get people seeing, I think people are getting lost in some of this because it's exciting. You can go there and make a model. Everybody's doing it. You want to be part of the crowd. Really learn the basics. The basics are, hey, start small, walk up onto it, and also start practicing how to integrate the models, because you're not going to just have a systems model by itself. It doesn't do anything. It just sits there. So it's got to be talking to the other tools. It's got to be, and of course you could do it all in Cameo. Nothing wrong with that. I just don't think that's the best way to go. I don't know if this shows here, but I don't know if that's the right thing to do. To me, I like to be able to plug these in, make a workflow, and then you start. There's another layer, the analysis layer above that. There's an analytical engine on top of that. So you've got this workflow going. You got an engine up here, and you're cranking out. One of the fun things I do is Friday night, press play, go home. Sunday morning, I have 500 gigs of data I got to figure out what to do with. So I'm working all weekend drinking beer because I know how to turn on a workflow and let it go. So it's fun. Oh, I was going to show you these real quick. These are in that same folder. Again, we're missing some of the stuff, the complexity of just performing a sensitivity study. This is very complex. This is a whole sensitivity study for that tool where I actually open the tool from from Jupyter Lab and run it through this study set. This takes I have to turn this on AWS. I have to have about 400 cores. It takes several hours to run. So it's all here. But it gives you a starting point if you're interested in learning some of the stuff or looking into it. Here's the results report. So we're about done. The results, the results are complicated. How do you deal with all this data? It's reams and reams of data and trying to figure out what the model looks like. And this analysis does something fun. It informs the model. And then the model is then informing the other model again. So they start talking back to each other, and you start changing your model based on other inputs, not just what you're typing, not what you're dragging onto a block canvas. So, all right, I think that's it.
Questions?
Yeah. I can put it there. It's on Teamwork Cloud, so I don't have it saved locally. I can make one, throw it up on that little repo. It's really pretty easy.
So I just had a quick question for maybe some of the variables that you wouldn't necessarily think about putting in Cameo. For instance, I'm thinking like environmental. Maybe in between the hospital and the drop-off point of the drone, there's a huge mountain that you're not seeing, and Cameo doesn't really necessarily model that. How do you go about inputting those? Or let's say it's a rainy day and the drones don't work as well. How do you incorporate that into your simulation?
So you can do that I can pull landscape data into that tool there. I can actually pull 3D ground data in there. And Cameo can tell you that. It can tell you what's your area of interest. And then when you open up our little tool here, it will automatically go out to the web, grab that area of interest location, pull it in, and now you're flying in your real world. And you can also have fun, like, your area of interest can be, you can make a whole bunch of these cool instances of a square, a rectangle. Your area of interest could be the shape of a state. It could be rotated. And you can do that with that same methodology of just making a table in Cameo and then acting like you're right-clicking a tree. So you add an area of interest, then you add some sort of shape, some sort of center point, some sort of rotation, add multiple points to it. It can be curves or splines. You can tell it that, and build that same tree structure out, or tree view structure, just like we did with that little model in Cameo there. So, yeah, I think you got to start thinking about it. You can model almost anything you want in that tool. You can tell the rest of the world exactly what you're thinking and exactly what you want to test in Cameo or in any other tool, but Cameo works great too. You can do it.
Other questions?
It's Miller time.
So that
Aw, man.
last notebook you had up doesn't appear to be in the GitLab, right?
Oh, it's not? All right, I'll take a look. I'll make sure it's there. It should be. I thought it was in there. Yeah, so in models, complex. Yeah, so it's in complex model. I have a simple model set. I have a complex model set. That's the whole analysis that kind of goes through. It was a bunch of work, and it turns out it wasn't. I kind of overdid it, but I was trying to do something for somebody as part of an educational program, not really business related.
All right. Any parting questions? Okay.
Any comments? No questions? I'd like to hear some comments. What do you think about that?
Totally agree with you that the purpose of the model is not the model. It's a very common trap that I see with a lot of our new modelers. They go to the classes, they get trained in the technology, they drink lemonade and go, yeah, this is going to solve all the problems.
Yeah.
And we get trapped in, well, wait, I've got to make all these views. I need to fully populate. That's kind of my no doubt die. I mean, it's not dead, but
Yeah.
it kind of died. Because everybody thought, oh, well, I have to make all these views.
Yeah, I
You're
see.
not answering a question.
It's not informing anything. And I see a lot of, well, I want to make a model, and the objective is to use SysML to do something like that. That's not an objective of your model. You're not using SysML for any, that's a modeling language. It'd be like me saying, I want to make a simulation. I want to use Python to do something. Like, that's not what I'm doing. I'm writing a sim, and the sim is going to do something. And so what is the objective of the sim? It's got to do these things. It's got to tell this other sim what to do. It's got to receive this information and lay that out. If you don't lay it out, your model's going to end up being a weed. It looks like, to me, when I look at these things, it's a weed.
I like that you're giving the model teeth.
Yeah.
I remember back, learning program, I learned Pascal, okay. Now, I
you're dating
had been
yourself.
doing assembly work before that time, so I'm getting into Pascal, and it's like, well, this is really elegant and everything, but man, I can't even print something on the screen. What good is it?
Mm-hmm.
Well, that's like the difference. This is like the difference between Pascal and C.
Yeah.
They look an awful lot alike, but you could send a rocket to the moon with C.
Mm-hmm.
So I think it's amazing that you've given it teeth.
Yeah, thanks.
That's very inspirational. Thank you.
All right. Anybody want to tell me it stinks? I don't mind. You can tell me. You can tell me by email if you'd like.
All righty. Thanks, John, very much.
Yep.
So that is a wrap for this track today. But we will, we've got a couple of keynotes in the morning, but then this track will open back up at 10 a.m. with with Brian Moberly, our YouTube video star. All right. I'll see y'all at Topgolf. Have a good evening.
Thanks, guys.